So in this video, we're going to look at interquartile range, which we refer to as IQR, and then we're going to finish with some box plots. Okay, so hopefully a nice quick video. So first, let's go and have a little look at why we would use interquartile range. So when we look at range or interquartile range, we're measuring the spread of data and how consistent the data, that should say, is. Okay, so for example, if you have a large range or a large interquartile range, that means that your data is spread out and it might not be consistent. The reason we might use range, interquartile range over range, is if you have any outliers. So if you have any really small or really large numbers, it won't take them into account if we use the interquartile range instead, because that just looks at the middle 50% of the data. And it might be better to use this sometimes to avoid any outliers. So we're going to look at first recapping what each one of these means. So the range is, hopefully you will remember from the last video, is the highest subtract the lowest, which in this case is nice and easy. The interquartile range, because we're looking for the middle quarter, the middle 50%, we are doing Q3 minus Q1, which sometimes we refer to as upper quartile, subtract the lower quartile. So that just means if you have your numbers in order, you would take the number that is a quarter of the way up, and we call that quartile 1, and then you would take the number that is 3/4 of the way up the data, we'll call that quartile 3, and then you would subtract them, and that will give you the middle 50%. So let's picture this number line, just so I can hopefully explain that a little bit more visually. If we had a set of numbers and you want to work out the middle 50%, we are talking about from the first quarter to the third quarter, and we can look at the spread of that data, and that would avoid any outliers. So just to go over that, some key points again. So the lower quartile, or Q1, is the value a quarter of the way up through the data. Q2, we don't really call it Q2, but that is the median, so that's the middle number. So that is 50% up our way through the data, which is a half of the way. And then we have Q3, which is 3/4 of the way through the data. So what we're going to do now is we're going to have a little look at a question. So we're going to have a look and say, okay, I'm going to compare these two classes. I have class A and I have class B. Different number of students in each class, but they've done a test, and these are the scores. And what I'm going to do is I'm going to work out the interquartile range for each class, and then once I've done that, I'm going to draw a box plot for them both, because interquartile range and box plots go hand in hand. So one of them has an odd number of students. So this first one, if you look, if we count them, it should have 11 students in the class. So what I'm going to do first is, because it's always nice to split them up first into two groups, is find quartile 2, which is the median. So hopefully that is super easy in this question, because it's going to be that middle number there, where is my median, and we call that quartile 2. Now this naturally splits the numbers up into the lower set of data and the upper set of data. So that's where the lower and the upper quartiles come from. So if I look at the lower numbers, what we basically do is we want to find the median of the lower. Okay, so that will give us the first quarter. So in this question, quartile 1, or the lower quartile, is 15, because that is the median of the lower quartile. So that is a quarter of the way up my data. This is a half of the way up. Now we want to know where 3/4 is. So you go to the upper numbers and you find your median, and that is quartile 3. In other words, that is 3/4 of the way up the data. So if we're going to look for interquartile range, you're going to do interquartile range. We do Q3 and we subtract Q1. So we do 23 and I am going to subtract 15. So my answer is going to be 8. So that is my interquartile range for class A. So I can say the spread of data for this first one is across 8 numbers. Okay, so now if I do class B, I'm going to change the colour so we don't get a little bit confused. So class B, this time it's an even number. Okay, we have 8 numbers. So if I want to work out the middle first, you should see that the middle is going to be where the 12 and the 12 is, because I have 8 numbers, and 8 plus 1 divided by 2 is 4.5. So it's between the 4th number and the 5th number. So this one's nice and easy, but you would usually just add them together and divide by 2. So I know that Q2 is 12. Okay, now when we work out quartile 1 and quartile 2, when I split my numbers up, I'm going to actually include them 2 numbers, because neither of them were in the actual position of the middle. And then what we're going to do is I need to find the median of the lower and the median of the upper. So again, because there's 4 numbers in the first group, the 2 that are in the middle are 10 and 11. So 10 plus 11 divided by 2, that is going to give me 10.5, and that is quartile 1. And then the upper quartile is between 17 and 18. So if we add them together and divide by 2, that's going to be 17.5. So all I have to do now is do for the interquartile range is I'm going to do 17.5 and I'm going to subtract 10.5. So in this question, my answer is 7. So you can see for class B, their interquartile range is 7. So I could say for this one that their data is more consistent. Or I could word it as class A, their interquartile range is higher. So that means their data is more spread out. So they're just 2 ways that you can word comparing these 2 classrooms in terms of interquartile range. What I'm going to do now with this is I'm going to plot them both on a box plot at the bottom. So I'm going to start with class A. So first thing I'm going to do is label it. So this is class A's results. And I'm just going to put in my information. So we also have to put in the lowest and the highest when it comes to box plots. So my lowest value, if we go back up, is 13. So if I look at my graph, 15 is about here. So that means 13 can go here. Then I'm going to plot my biggest value, which is 30. So that's going to go here. Then I'm going to put my quartiles in. So I have got 15 as quartile 1. I'm going to put 18 in because that is my median. And then I'm going to put 23 in because that is my quartile 3. And what you do is you join the quartiles up. So quartile 1, quartile 2, and quartile 3. And then you just join the ends up with a straight line. And that is our box plot for class A. So then class B, I'm going to do exactly the same. So my lowest in this question is 9. My highest is 35. Then when it comes to my quartiles, I have 10.5. It's going to be about here. I have 12, which is going to be about here. And then we have 17.5, which is going to be about here. So if I join my boxes together, my quartiles, and then I join them up, that's what that looks like. So we can clearly see from the box plots that if we were going to use the normal range, class B would have actually been higher. But if you look at the data at the top, they have an outlier. It's 35. So this one was the outlier. So that's why if you look at the box, class B's box is a lot shorter than class A's box. And that's where the statement comes from. So their data is closer together. It is more consistent. They just had this little outlier that would have affected our results if we used that with the range.